Right. Good afternoon, everybody. We are going to be finishing up, was it 14C, I think it was? And we are going to, after that, talk a little bit about the test. So let's go ahead and get started. You guys can say hi to me in the comments section, and if you guys have any questions at all, go ahead and ask. So today we're going to be looking at, first of all, like I said, 14C. Let me see if I can pull it up in the book here. Make sure you check out, I've already posted the review guide for you guys. The test this time is not going to be as long as last time, so we got only one chapter, and it wasn't a very long chapter, right? It was only like A, B, and C, so we got refraction, you've got total internal reflection, and you've got the lenses. Now you do have two different kinds of lenses, both the converging and diverging stuff, so expect to have questions on both of those kinds. And so make sure you guys check up on Google Classroom and see that we have the review up on Google Classroom. So let me see if I can pull up the homework and we'll go through that. All right. So this one was pretty much all about critical angles. And let me see, we did 14C, just 1 and 4, and I think 4 had multiple parts to it, right? Maybe. Yeah, 14 had multiple parts to it. Okay, so let's go ahead and do that now. All right. So 14, number 1, we have glycerin, which is used to make soap and other personal care products. Glycerin is actually a natural component of natural soap. Or, I mean, I don't know if it's natural soap, if that's the way you call it, but the original soap, basically if you take fat and react it with sodium hydroxide or lye, which is known as, so sodium hydroxide is known as lye, you'll get out your fatty acids, salts, which is soap, and glycerin, okay? Glycerin is a natural moisturizer. All right, so it's used to make soap and other personal care products. Find the critical angle for light traveling from glycerin into air. And so we can go ahead and do that. Your equation, if you recall, was simply the critical angle equals the inverse sine of your index of refraction of the material that has the refraction in it, and the index of refraction of the incident material. So where the light's coming from and where it's going into. Okay? And so one of the biggest mistakes that you could possibly make on these kinds of problems is just switching NR and NI. And so that's an easy mistake to make. So make sure you don't do that. All right, so number 1, we have glycerin. It's used to make soap, and we said we're going to find the critical angle, so we're just going to plug it in. Here's the critical angle is going to be the inverse sine of, now which one goes on top? It's going from, it's traveling from glycerin, so that's the incident material. So we're going to put our 1.473 here on the bottom. And on the top, it's going into air, 1. Notice if we switch those, you wouldn't be able to get any kind of answer. So this is the inverse sine. Let's even do that right now. So make sure that your mode is set for degree mode, right? And let's go ahead and plug this in. So if we have the inverse sine, so second sine, you're going to get inverse sine of 1 over 1.473, and we get out 42 point, well, round it up to 42.8 degrees. 42.8 degrees. Now notice, let's just for fun see what happens if we switch them. Right? Let me just show you guys. So if you switch them and put 1.473 divided by 1, what you're going to get is an error. And well, why do we get an error? Because the sign of something can never be more than 1, right? The maximum you can get is 1, or it's between -1 and 1 inclusive, right? And so This is saying, okay, you get an inverse sign of something that's larger than 1, then that's impossible. It's impossible to have the inverse sign of something larger than 1. And what would that mean? If you had something where you'd try to calculate the critical angle for something that was like this, where the bigger number's on top and the smaller number's on the bottom, you would simply just have no critical angle. There would be no angle at which all of the light was internally reflected. So no possible angle. All right, that's what would be the case. Okay, so that's number 1. Number 4, going down here to number 4. Which has a smaller critical angle? Let's just go ahead and solve for both of them. I wouldn't, so it says show your work, so you don't want to just guess on this one. All right, so, but we can, make a guess ahead of time and say, okay, well, it would make sense for diamond, right, to have the smallest critical angle here because, it's diamond, it's the expensive material, plus diamond has a larger index of refraction. But let's actually go ahead and calculate these things. Okay, so you have a critical angle for, let's do, what do you want to do first? Let's do the cubit zirconia. We'll call that cubit CZ. Okay, so this is the critical angle of cubit zirconia, and so this is going to be the inverse sine of 1 over what? That's 2.2. Right, and we're always going to be putting here, in this case, the value for air on top, right? So 1 on top. Obviously, if the gemstones were in some other material like water or oil, this number all of a sudden would change, right? But now if it's just asking smaller critical air, well, it says right here in air, so we're just going to put 1 here on top. All right, so this is going to be 1 over 2.2, which is 27. That's pretty small. That means all angles greater than 27 degrees are going to be totally internally reflected, which is pretty significant. So that's all the angles, so it pretty much has to come at, close to perpendicular, right? And if it's not, it's going to be internally reflected. And so what happens is for these gemstones, when the light comes in, it's actually internally reflected quite a bit until it hits like one specific face, or it hits the face in a certain way that the light comes straight out. And so that's how they're sparkly. So most of the light stays in, but then more of the light gets concentrated at these certain points at which like the light's going to come out and sparkle, and you'll notice it there. So it's essentially taking some of the light, so the light's not going to be able to stay inside a gemstone. It's eventually going to come out after bouncing around a lot, and that's where the cut comes into play, right? You want to cut the gemstone specifically such that you can get the light to come out at certain spots and make it look like it's sparkling, right? So that's done on purpose. All right. So we have the critical angle once again for diamond. It's going to be the inverse sine of 1 over 2.419. Let's get that. Inverse sine of 1 over 2.419. And that gets us 24.4. 24.4 degrees. What was the other one? That was 27.0. Okay. So we'll just put that in 27.0 degrees. All right. And so we just say, okay, the question is, which has the smaller critical angle? Well, this one, right? 24.4 is smaller than 27.0. So this is smaller. So we say diamond has the smaller critical angle. All right, and that makes sense. It goes along with our prediction because it's more expensive, because it's got the higher index of refraction. And by the way, there's actually a gemstone that does have a higher critical, it has a higher index of refraction and a smaller critical angle. I forget what it's called though, but it's actually got a larger index of refraction than diamond. Pretty cool. But it's actually cheaper. But so it's not necessarily just the more expensive one that is better. But most of the time, diamond is pretty awesome, and it's going to beat other gemstones in a lot of different ways. So anyway, that's pretty much it. All right, we have a test coming up, so no need to rush it. I hope you guys did manage to watch those videos. Like I said, we can't really do a lab, and I think there's no point in us actually going through having you guys do all those calculations with those videos, because they're the same kind of calculations that we've done. And the whole point in doing a lab is so you can do the hands-on work, right? And if you're not doing the hands-on work, I'll just let you guys watch the videos and we're good. So please, guys, do watch the videos. There are 2 demo videos about this kind of index refraction and those refraction, all that kind of stuff. So make sure you watch those videos. Yeah, Snell's Law, and the other one was something, some guy messing around with corn oil and broken glass. So be sure to check those out. They're actually pretty cool. But yeah, that's it. You just watch them and that's it. Now, we have, like I said, a test coming up. You guys got plenty of time to review for this. This homework, however, I'm going to make this due on Friday. And so we'll go over the answers on Friday. So please treat this as a homework. You are going to get a grade for it. So treat it as a homework, do this. And it's also going to serve as your review. All right, so go through these problems. It's up on Google Classroom. And then we'll talk about the answers on Friday. And your test is going to be on Monday. So that's it. I'm done for today. Do you guys have any questions? Anything at all? Hannah, Adam, anything at all? And nope. Okay, good. I thought this section wasn't too bad, so hopefully you guys make some sense of it and test on Monday. Guys, let's all do really, really well on this test. So I know it's open notes, but that doesn't mean you guys can't make mistakes. So please try to make sure you have the correct units on things, double check your answers, and get this stuff right. This is a test. I think you guys can all do well. We've done the ray diagrams for mirrors, so you guys can do the ray diagrams for lenses. And so yeah, so good luck. We'll talk on Monday. So just this is homework. Yeah, this is the only homework. That's it. How's the chess tournament? The chess tournament's going all right. Adam, have you won your bracket? I was expecting you're probably winning your bracket. I am, I believe, leading in my bracket. I've won 2 games and I got a couple games left. Just going, it takes a little bit of time. You did win. Awesome. All right. And then we have, I don't know about the middle bracket, who won in that one and all that kind of stuff. We'll see. So, and then I think as soon as the first, 3, like everybody's all done their initial games, then our final 3 will be playing. So Adam is in the final 3 and we'll see how that goes. Cool. So yeah, once again, please do watch those videos with the demos. This is your only homework due on Friday, and I will sign out. Have a nice rest of your afternoon. It's a nice day out. Go outside. And obviously stay away from people, at least 6 feet away. See ya.